They give us a margin of error in any type of statistics. Where they're going to give you a statistic, oh goodness sakes, are you kidding me? They give you statistics, and the statistics at the very bottom, they're going to give you a margin of error of plus or minus 3% or 5%. We've talked about this already a little bit. That's called a margin of error. They come up with that by using what is called a confidence interval. They're going to be 99% confident this number is going to be true. That means they're going to be 1% confident it's not going to be true. Don't steal my passcode. ... That means you're going to be 1% confident it's not going to be true. But then it's called a margin of error, and they have a confidence interval of it's going to be this value plus or minus 3% or plus or minus 5%. They're not quite sure what it's going to be. But they can say with respect to a confidence, it's going to be between these two values. Well, that's what we're going to be working on for the next week here. It's called a confidence interval. Strange stat of the day, average life expectancy of an enemy soldier in a Chuck Norris film is 4 seconds. You guys probably don't even remember Chuck Norris anymore. Cost of raising a medium-sized dog to age 11, $6,400. Medium-sized dog, $6,400 to raise them. You got all the shots. You got to go to the vets. You got worms you got to deal with. You got dog food you got to worry about. Okay, $6,400. These are estimates of the population. Okay, these are estimates of a population. When you're dealing with a parameter, you're dealing with talking about the population. Once again, parameters are dealing with populations. Okay, these are all things that we have talked about. A point estimate. When we talk about a point estimate, it's a specific numerical estimate of the parameter. And the parameter, once again, deals with a population. When you deal with a point estimate, it's a specific estimate of the parameter. And when you talk about a population, that's what we're trying to estimate. Now, if you want to do a study, you go out to Dr. Gerber out here, the vet, the Country Corner vet place out here. And you ask him, can I survey your people that are coming in for their vaccines every year? Okay, you gotta get yearly shots for your dog. Okay? Yearly shots for your dog. Can I survey them? And in that survey you sit there and ask, okay, how much a month do you think you spend in dog food? Okay, how much a month do you spend in dog food? Or how much a week you spend in dog food? Or if you go buy a bag of food, how long does that last? And then you can figure out how much they spend in dog food. Well, you have the vet bill. There's no, yes there is, but most people don't have it. There's no medical insurance for your dogs. Okay, and like, you guys are all covered with medical insurance. I'm covered with medical insurance. If something would happen to you, you go to the hospital, you get taken care of at the hospital. The medical insurance will pay 80%, 90% of that money that it costs to be in the hospital. And your family might have to pick up 10% or 5% or maybe nothing of that medical bill. Okay, dogs and cats don't have that. Pets usually don't have that. So when they go to the doctor, it is what what it is. I mean, you have to pay for shots, and you have to pay for this, or you have to pay for that. If you have a surgery on your dog, hey, you have to pay for that. Usually that's around $500, $600, $700, $800. Okay, you have to pay that out of your pocket if you want Rover to stick around. Okay? If you don't want Rover to stick around, we have that other shot that goes into them. Okay, that's a sad shot. Okay, that's the sad shot that puts tears in people's eyes. Because you have a dog that's been around for quite a long time. Next thing you know, dog's not there anymore. Okay? So, those are all medical expenses for a dog, or for a cat, or any of your pets. Well, you take a survey, and you keep on collecting the survey of all the dogs that come out there. And you start gathering all this information. And you come down to the idea it costs $6,400 roughly to have a medium-sized dog. The point estimate would be you collecting data out there at Dr. Gerber's. Okay, Country Corner Vet. That's you taking that. That is a point estimate. The best point estimate for a population mean is just a sample mean. Okay, you just take a point estimate. Okay, we have $6,400. Dr. Gerber's out there with all of our surveys. I average them up at $6,400. That's my point estimate. That's the best you can do to estimate a population. Now, if you go out to California, good old Fifi out there in California, they have spa days. They take their dogs to spa days out there. I don't know if they get a massage, they get groomed, they get to sit in a hot tub for a little bit. They have spa days. They get their nails done. It doesn't matter if it's a boy or a girl dog, they still get their nails done. Old Fifi out there, they get pampered pretty good out in California. Or if you go to any type of rich suburb anywhere. Yeah, they have spa days for your dogs. But what you can do is you can take one vet office and track medium-sized dogs to age 11 and find what the cost is. Okay, that's what you would do. The sample mean is a better estimator than the sample median or mode. The sample mean is the better estimator. Once again, we're trying to get an estimate. We're trying to get a guesstimate down here. We don't know for a fact what the population mean would be, but we're trying to get a good guesstimate to this. Well, a good guesstimate for that point estimate is going to be your sample mean, not your median or mode. And once again, a lot of this information you're going to be asked. You're going to be asked this on a quiz, just like you were asked a couple questions, fill-in questions. You're going to be asked this. I'm going to give me a property of a good estimator. A good estimator. We are estimating a dog, how much it costs for Rover to get to age 11. Well, properties of a good estimator. One estimator should be unbiased. PetSmart should not be doing the survey. Why? Because PetSmart is in the job, in the business to sell dogs. And if PetSmart sits there and says, it's going to cost you $6,000 or $7,000 to raise this dog to age 11, that's sticker shock for some people. It's like, oh, I got to spend that much money on Rover? I I could get $7,000. Well, it's over 11 years, but still they sit there and go, oh my gosh, that's a lot of money. Especially if you have little kids or something, you know, I gotta buy diapers, I gotta buy formula, I gotta buy clothes for my kids. I got graduation, I got proms, I gotta pay for dresses. That's a lot of money. I don't know if I can put $7,000 into Rover here. So, PetSmart wouldn't be a good thing, because what they would want to do is they want to be biased and say, oh, it's only going to give you a couple $1,000, don't worry about it, it's over 10 years, 11 years, it's not going to cost you much a year. Once again, you will need to be able to give me this information. The first one is typically the one when I ask you the question, give me a property of a good estimator that's unbiased. Second one, estimator should be consistent as sample size increases. Once again, law of large numbers. The value of the estimator approaches the value of the parameter estimated. Law of large numbers. Told you it was one of the biggest properties of statistics. Any type of studies that you do, any type of research that you do and you're collecting data, the law of large numbers is a huge thing. I haven't read up on the data, but they told me, I just heard an estimate. You know, they're Pfizer Medicals has a vaccine. Says 90% effective. Don't know what the sample size was. Don't know anything about anything with regards to the sample size. But I would tend to think if you have a company that's Pfizer Medicals, they're going to have a large sample. They're going to do the studies right. Because if you only study 100 people, and 90 of them it was effective for, yeah, it's good for those 100 or 90 to 100 people, but take that over a population of 1 million. Is it going to work for that? What type of adverse effects are going to happen? Talk to you. Somebody was talking to me, how can it be 90% effective? This is a new virus and so on and so forth. Like, well, when you guys were little, you got an MMR shot when you were little, a vaccine, mumps, measles, and rubella. None of you have had to deal with mumps and measles. When I was growing up, I had measles. I think I had mumps also. I had chickenpox. Okay, there are shots now, vaccine shots, that will take care of chickenpox, that are quite effective. Mumps and measles, almost non-existent anymore, which means they're pretty effective. Estimator should be relatively efficient estimator, best estimator with small variance. Now we're going to go back to a problem we didn't do this exact problem, but this type of problem we did. An average vehicle registered in the United States is 8 years old or 96 months. That's the average vehicle. Assume the standard deviation is 16 months. If a random sample of 36 vehicles is selected, find the probability the mean age of their mean age is between 90 and 100 months. This is just a type of problem we did. We have a mean is equal to 96 months. that's not good. A mean of 96 months. We have a standard deviation. Sorry, it messes with the old man's brain. When I put my pen in one spot, it writes in a different spot. Okay, I can't handle it. We have a standard deviation of 16 months. We are taking a sample of 36 vehicles. And we want to see what is the probability the mean, their mean score is going to be between 90 and 100 months. So we need to calculate a Z for 90 and a Z for 100. Oh my gosh. So we need to calculate a Z for 90 and a Z for 100. And this goes back to what we just did. So we have 90 minus 96 divided by a standard deviation of 16 divided by a square root of 36. Find a Z-score for that. Find a Z-score for 100. Do your bell-shaped curve. Go to your Z-table. Okay, once again, this is exactly what we just did. How many do we get for the Z-scores? Negative 2 point what? What's the other one? So we go to our table, get our areas. Lucas, what do you get for the two areas?
0.4878 and 0.4332.
Okay, we good with those values? Okay, so what do we have to do with these, Mitchell? Add them together. So we're going to go 0.4878 plus 0.4332, and what do you come up with? 0.9 what? So what's the probability that your mean age is going to be between 90 and 100 months? If I take 36 cars and I take the average of those 36 cars, there's a 92% chance their mean will be between somewhere 90 to 100 months. This is the percent probability the mean age of the sample is between 90 and 100 months. 92.1% chance. It can also be stated as a confidence that the mean, we are 92% confident we're 92.1% confident the mean will lie in between those two. We're 92.1% confident that the mean is going to lie in between 90 months and 100 months. So there's a lot of things that we have been doing that's going to just transfer into what we're doing in this chapter. We talked about an interval estimate. It is an interval. And we're talking about an interval or a range of values used to estimate a parameter. They may or may not contain the value of the parameter being estimated. So we have an interval estimate. It is a range of values. And we've done this already. A range of values. Used to estimate a parameter. This may or may not contain the parameter being estimated. And once again, the parameter deals with the population. Last question on your test. 60 stat students took a test. Mean was 72, standard deviation 8. Professor wants the middle 50% of the grades to be C's. Well, he's dealing with a 50% confidence interval then. We're trying to find a range of values. You had to calculate what is the minimum and maximum score for these C values. Well, that's what we're going to be dealing with here. That's like an interval estimate. The confidence level.
Maybe.
It's a probability. When you talk about a confidence level, is a probability that the estimate will contain a parameter. Assuming the law of large numbers, the samples are selected and the estimation process on the same parameter is repeatable. Like everything in this class, you need to have a day one of just a lot of philosophy theory behind what we're dealing with in the chapter. Sort of what we have to get through again today. Tomorrow we'll get into actual numerical values of problems. But we will use these. We'll use this terminology here. Confidence level. It's a probability that an estimate will contain a parameter. Just like the survey I talked about at the very beginning. Okay, you talk about surveys. 37% of the people are going to vote this way, plus or minus 5%. So they feel the population will be anywhere between 32 and 42% chance, or 42%. Okay? So that's, you're getting a range of values, and you hope that the population parameter is going to lie somewhere in there. All good experiments are repeatable. All good experiments are repeatable. That's why when you do experiments, you have to write down a process. Because if you have some finding you don't believe Sir Figure of Isaac Newton was correct, that acceleration of gravity was approximately 9.81 meters per second squared, and you just proved that, well, you have to be able to publish what you're talking about, and people have to follow your exact same process and come down to the exact same results. Confidence interval. It is a specific interval estimate of a parameter determined by using data from a sample and by using the specific confidence level of the estimate. The interval estimate and the confidence interval are fairly similar to each other. Specific interval estimate of a parameter defined by using data from a sample and by using specific confidence level of estimate. What we will be doing. We have a sample size n. We'll take a sample of size n. Take a sample size n. We will calculate an interval, which is using a z-scores to illustrate a confidence, that's our confidence level, that a population mean will be somewhere within that interval, your confidence interval. Take a sample size n, we'll calculate an interval using z-scores to illustrate a confidence level that the population mean will be somewhere in between that interval. And that's what we're trying to do. We're giving a good guesstimate. That's what statisticians do. Once again, tomorrow we'll get into actual numerical problems here. This will probably be the easiest chapter that we go through. Should be. Not that anything's really that difficult in this class, if you work at it. Most confidence levels are 90, 95, and 99%. If you're saying you're 99% confident something's going to happen, you're probably going to do it. If I told you, if you would wager $100 on something, and I'm 99% confident you're going to win $1,000, would you do it? Take $100 out of your bank account, and I'm 99% confident that you're going to get $1,000 back. Would you do it? Yeah, I'd do it. I'd be all over that. we will stop there today. And once again, tomorrow we'll get into more numerical problems. No homework for tonight. We just sort of have to get through the preliminary stuff here. Tomorrow we'll get going with some numerical values, numerical problems.